Okay, this is the first video of chapter 1, and we're going to start with 1.1, linear equations in one variable. You'll notice this course builds a lot, so this video is linear equations in one variable. Chapter 3, we're going to do linear equations in two variables, and it kind of just, all the topics will end up building sort of on each other. So the first thing we want to make sure that you can do is distinguish between an expression and an equation. And in doing this, I really want to define a couple terms. So an expression is anything containing a collection of, and here are your keywords, constants. Constants are things that cannot change. So something like the number 5, there's nothing attached to it that could make it change, and so it's a constant. And so constants. Variables. Variables are things that can change. So these are things like the letter x. X is a variable because you can put different things in for x depending upon the situation. It can also include operations. So it could have multiplication, it could have division, subtraction, and or grouping. So what that means is that you could have something like 5, and that's an expression. You could have something like 5x, and that's an expression. You could have something like 5x plus 3, and that would be an expression. So it's a collection of these constants, variables, operations, and or grouping. So an algebraic equation is a statement that two algebraic expressions are equal. So in other words, if I want to change these expressions into an equation, I could say 5 equals 5x. So it's one expression equal to another. So the key difference is that an equation does have an equality symbol, whereas an expression does not. And why is that important? Well, important because an equation can be solved. There's a value for x that will make the equation true, whereas an expression cannot be solved. Now, what can you do with an expression? You can simplify an expression, but you cannot solve an expression. So when you're looking at a question in the homework, or if you're looking at a question on a test, you want to decide, is this something that I'm solving, or is this something that I'm simplifying? So if you look at these two examples down here, one of these is an equation and one of these is an expression. And the easiest way to tell is the equal sign. If there's an equal sign, it's an equation. And if it's an equation, there's a value of x that will make this equation true. Whereas if there's no equal sign, it's an expression, and you can simply simplify. So if there was another x term, so let's say this was 2x plus 3x, you could simplify it to 5x minus 7, but you wouldn't be able to say the value of x that will make the equation true. So in this chapter, we're going to be looking at linear equations. So there's a couple of factors that make something a linear equation. The first thing is that it contains only real numbers. And the variables that are included, okay, there's only going to be one of them, and it has to be raised to the first power, meaning it's going to have an exponent of 1. Now you're never going to see that exponent of 1, it's just going to be written as an x, but whenever you have a variable, it's expected that there is an exponent 1 there, or assumed is a better word there. Linear equations can be solved. And when they're solved, there's only one solution ever. Linear equations have one solution that make it true, and you can always check to see if your answer is correct. So linear equations, how do you identify if something is linear? Well, it can be written in this form, and it can be written in a lot of different forms, but for some reason this is the form that your textbook decided. And so it's going to be written as ax plus b equals c. And what's important about this is that a, b, and c have to be real numbers. The a cannot equal 0. And it can't equal 0 because if a was 0, there'd be no variable, because 0 times x would make it disappear. It would just be b equals c. And so it has one variable, and that variable is raised to the exponent 1. So what I want you to do is look at these 5 equations and decide which of these are linear and which of these are non-linear. So pause the video, give it a think, and then resume when you're ready. So I'm assuming you've thought this through and you pause the video. And so we're going to look through and say which ones are linear, which ones are non-linear, and why. So this first equation is linear. And it might look a little weird the way it's written, but x over 2 means x divided by 2. You can also show x divided by 2 by putting 1/2 x. 1/2 x is the same as x divided by 2. And then if I kept rewriting the equation, you can see that it's written in ax plus b equals c form. The exponent on the x is a 1, so this is linear. This next equation, hopefully you saw right away that it's nonlinear because there's an exponent of 2 on the variable. So this is nonlinear. In fact, this is quadratic, which again, we will build into in this course. Oh, for some reason that didn't come up. This next one, ax plus b equals c, that is very linear. This next one almost looks like it's linear because you could say, yeah, the exponent on x is 1, but it's not written in ax plus b equals c form. So if I tried to rewrite it like that, I would say that this is 2 times 1 over x. Where's my letters keep disappearing? Minus 2/3 equals 5. So if I wanted to write it with the x on the top, I would put x to the negative 1. So all of a sudden the exponent on x is not 1, it's negative 1. So this is nonlinear. And this one, anytime you see something funky, so if you see the x in a denominator, or for this one, you see an x in a radical, you can automatically say nonlinear. For anybody who's taken some math, you could know that the exponent on this is a 1/2. But if you don't know that, don't worry, we will be covering that in this course. But this is nonlinear. All right, moving on. So we said that linear equations can be solved and that they will only have one solution. So my question to you is, how do you determine if what you solved is actually the solution to the equation? So if I said, is 8 the solution to x plus 2 equals 10? We're going to learn the format for how to check. So what I do is I like to draw a line down from the equal sign. And so then I work on the left side separately to the right side. So the right side, nothing's going to happen, it's 10. So what I'm checking is, can I make the left side equal to the right side when I put 8 in for x? So I'm going to replace the x with an 8 and say, does 8 plus 2 equal 10? Yes, it does. My left side equals my right side, so it worked. Some people will actually work on them separately. They'll say, hey, this is the left side. The left side is x plus 2. If I put in x is 8, I get 10. My right side is just 10. So since I got my left side equal to my right side, 8 is the solution. So how do you state that something's solution? So, I mean, if it was me, we often get to the answer of a question and we get, oh, x equals 8. But if you want to state that the solution set is 8, what you do is you use those solution set brackets, so kind of a squiggly line, and you put the 8 in it. In this course, we will get to a point where we'll be solving for things, and some of them won't be solutions. And so you might want to say reject a solution. And so you'd say, okay, only this one is in the solution set. All right, what I would recommend is going to your homework, looking at what questions you can do now, and then moving on to the next video.